Okay, so this is synthetic division. If you don't like this, don't use it. I'm not going to force you to do it. I dislike it strongly, so I will never use it. The reason long division is called long division is because it's well long. Okay. Henry, do you remember synthetic division?
Yes.
Okay, tell me what to do then.
You put a 0 in the first two because you can just add a 0.
Carry me? Yeah.
No, right above it, right there.
Right there, and then so you add that together. That's just 2.
Okay.
Multiply by 1. Put
Okay. Okay.
That there.
There's 2 there.
Yeah.
And then you're adding these?
Yeah.
Okay. 1 times 1 is 1. Good. -7. 1 times -7 is -7. Good. And 6. And 6 times 1 is 6.
It's -6.
Naturally. Okay, so thank you. Now, minus not right, sorry. Liam, what does that 2, 1, -7, and -6 actually mean? Yeah, so this is going to equal then, we have x minus 1, that's 2x cubed plus x squared minus 7x minus 6. Is this starting to come back a little bit for people? I hope. Yes? No? Too fast? I'm sorry, I got to ramble for this. I got 15 minutes to wrap this. All right, Arden, I'm picking on you. I'm not done factoring this question. What shall I do next, please? Yeah, we have to leave this, like this we're not going to touch, we've got to do the same thing. Arden, can you tell me, please, any number that will work to cancel that out? Yeah, well, no, sorry, that'll cancel, it'll make this 0, right? Because you're trying to make that 0, right? -1, I think, will work. See how nice I am? So f of -1 equals 2 times -1 cubed plus -1 squared minus 7 times -1 -6. There will be lots of things you have to work on in this class. I mean, as far as difficult work, but finding roots is something that you did in advanced functions, okay? I don't want you to spend half an hour finding the roots here, which will happily equal 0. Okay. Emily?
So x plus 1 is...
Very good. Great, wonderful, tremendous, even. Jeffrey, do you remember synthetic division from advanced functions? Okay. I don't remember it either, so don't feel bad. Does somebody help Jeffrey and myself with synthetic division, because I forget? We're going to just, because this is done, we still have to factor this thing, right? So you're going to divide the x plus 1 from there. Can I remember? I can't remember how to do
So
it.
you put -1
Okay.
over as to what you're dividing by.
Yeah.
And then you write the other, like the coefficients across the top.
Okay, put a 0 there.
Bring the 2 down.
Okay.
Multiply by -1. Then add those together. Write that number there, and then multiply that by -1.
Thank you.
Then add those, and then multiply again, and that is your remainder.
I don't know why I'm so against this. The C is not cool.
Bad fraction.
It is bad fraction. That's the issue. That's the issue, right?
Just that it's denominator.
Right, but then,
Except for the remainder.
But you have to remember that.
Okay. All right, Jeffrey, you cannot duck this question. It's your time to shine. Will you please factor 2x squared minus x minus 6 for the class, please? Will you factor this? Oh no, you're freezing. It's okay. I'll come back to you tomorrow. Don't worry. Just remember that. Don't freeze. Courtney, can you factor 2x squared minus x minus 6 for the class, please? Didn't you have like guys all have 90s in advanced functions? Did you never have this class with 90 advanced functions? Goodness, Nate, you did. Nate, how do you factor 2x squared minus x minus 6? Nate. M&A, good. Multiply to -12, add to -1, which is -4 and 3. So it's going to be equals x minus 1, x plus 1, 2x squared minus 4x plus 3x minus 6. X minus 1, x plus 1, 2x, x minus 2 plus 3x minus 2, which is x minus 1, x plus 1, minus 2x plus 3 and x minus 2. Okay, so that's all that factored. Now, before you ask, is there a quartic formula? Yes, there is. Mr. Kemp, I think, has it in his
Sign. I
Sorry?
think he has the quartic formula as a sign.
on his assignment. Okay, it's enormous though, like it's awful. Okay, so you can find all the roots. It's much easier to do it this way. All right, Courtney. So you don't have to duck this question. How does this going to help me on the graph doing all that factoring, or is that going to help me for my graph? All my roots. Okay, so I'm going to say I'm going to root with this one at 1 and 0. I'm going to root here at negative 1 and 0. I'm going to root here at negative 3 over 2 and 0. And I root here at 2 and 0. I'm also going to go all the way back to the beginning and get my y-intercept quickly as 0 and 6. It's my y-intercept. Sorry, I sort of went quickly there, but I just went back to get the y-intercept from it. And we'll talk about end behavior as we graph it here in a sec. Just slowly coming back from last semester, I hope. Or summer school or whatever you talk about this course. Hypothetically. Yeah, hypothetically. How are you feeling? Just coming back from last year, I hope? Yes? Factoring is fun. Okay, next page. We're actually going to graph this now. Yeah, that took 3 pages of rough work. Don't worry, this gets easier with calculus. Okay? It does. You don't believe me, but it will. Okay? One of the reasons I'm putting you through this today, so you can savor the joy of doing this quickly in a month or whatever we do. All right, so here's our graph. I have to get line here. 0 and 6, right? I should put it down here. Okay, so I'm going to count by 2's on my graph just so that, or I count by halves, I mean, so I can fit everything on there. So while you guys are doing that, I'm going to plot my roots and then I'll talk about end behavior and why I need that, okay? I'll put all my points on here. Take a second to do that. I'm going to put 1 and 0 right like this. I'm going to put negative 1 and 0 right like that. I'm going to put negative 3 over 2 and 0 just like that. I'm going to put 2 and 0 just like that. And I'm going to put 0 and 6 way up like this. Okay, so, sorry, I'm going too quickly. How are you this fine afternoon? We're just contemplating for the graph. We're very happy that you're here. That's awesome. Yes. Okay. 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 Evan, you need to go to guidance? Do you need to go to guidance? It's a question, not a statement. You do? Okay, go to guidance. Okay, so end behavior here right now. Who am I at? Karen, I think, right? Karen, am I you? Okay, this is a positive quartic graph. How does a positive quartic graph look? It looks like that. Very good. Okay. So what I'm going to do is I'm going to just sort of draw an arrow like this, up like that. I'm going to draw an arrow like this, just like that. Okay. How do I do the in-between points from this? Sorry? Connect the dots is basically it, okay? So this is going to go down sort of like this. This is going to go way up here. I didn't really think that would be possible, but that's okay. And that's going to go like that. I was going to get Michael to give you a double root, and I will tomorrow for your warm-up to show you how the double roots work, okay, where it just sort of nicks the line that doesn't bounces off it, okay?
There's like 2. How do you know, like, we were dealing with those a lot in Mr. Van Stratton's class, but how do you determine how many are in there? Because that could be like
If
6 or 2 or 4.
Because the thing is, if this was squared or cubed or something like that, then you could, that tells you how many roots there are.
You're saying make an equation from a graph?
Yeah.
That's why it says determine an equation, because we don't know which one. Yeah.
Okay, so here's the thing about that's difficult for this. okay? You don't actually know how high or low the graph actually goes, right? The range for this question is impossible to find, all right? Because right now, with calculus methods you do, okay? Does this go here? Probably not. Does it go here? I have no idea. If that's way up there, that could shoot down to here, we have no idea. The same thing, is this the highest point? Possible. Okay, not necessarily though, right? It's also going to infinity. So that's another thing that calculus is going to show us. So my domain here I can say is anything. Range is the question. Yeah, range is the eternal unknown for right now. You might be saying to yourself, who cares? I don't know the range, okay? If this is a thing that talks about your investments, how low do you go before you buy your stock? You probably want to know that, don't you? If this is your basketball shot, how much energy are you going to use to minimize your, maximize your chances? Okay, that's what this is all about here. Now, what I was trying to say, I'm going to formally get you to put this down before I get to the homework. The reason that calculus is useful to you, okay, or one of the reasons, is this graph right here is impossible to do in advanced functions, right? That graph right there, you would have no effect to know this if you were to get that, okay? With calculus, you can very easily do that. That has no roots. It's difficult to do, to solve, okay? So you can do very, very easily. I was going to get to exponential exponents, but it's not going to happen. I'm just going to write your homework on the board, and then I think we're going to stop. Okay, so what I want you to do tonight when you do this is do all the, for number 9 for most, it's going to be lots and lots of factoring. Okay, that's what's going to be. I want you to feel good about what we just did on the setup work for this. I only want you to actually physically put one to graph paper, right, okay, but you should be able to find all the roots and all that stuff. If you want to talk to them all, go ahead. I'm not going to stop you, okay, but today's lesson should have been subtitled factoring. Okay, so you have to be comfortable with it. You have to feel good. If you're not, you won't do practice tonight. Okay, that's Saturday practice this weekend or whatever. Sorry? Yeah, if it says the graph. I just want you guys, when I say cubic, quartic, linear, quadratic, all that stuff comes graphing tons of when we get to the calculus parts. Okay, I think we're almost done with view. I didn't really get to exponentials and logarithms and taking all that stuff, but I'm going to leave that probably until the units that you actually need them for. All right, so yeah, I think I'm done. Michael, do you have any words of wisdom before I stop?
Do your homework.
Yes. Do your homework. Good advice. Yes.
I do.
At 3:10.
Oh, 3 o'clock.
3:10.
We're dismissed at 3.
Why don't you tell me at 3 o'clock?